In this video, we're going to look at 3 examples of how to find antiderivatives using a technique called U-Substitution. The first example is to evaluate the integral of x to the 4th plus 5 to the 10th power times 4x to the 3rd dx. Example 2, or B, is to evaluate the integral of x to the 4th plus 5 to the 100th power times x to the 3rd dx. And then example 3, or C, is to evaluate the integral of the cube root, the 3rd root, of x to the 4th plus 5, and then on the outside of that times x to the 7th dx. So the key in all of these is to let u transform the integral from x to u and let u capture what's in parentheses or what's inside the radical. So in the first example, x to the 4th plus 5 is being raised to a power. We're going to let u be the single variable equal to x to the 4th plus 5 because it's easier to handle u to the 10th than x to the 4th plus 5 to the 10th. Then we need to equate the differentials, that is du with dx. Du would be 4 times x cubed dx. We can see that there is x to the 4th plus 5 in the integral. We call it u. There is 4x cubed dx. We'll call it du. And so the integral in variable x to the 4th plus 5 to the 10th times 4x cubed dx, with this u substitution, is transformed to an u integral, that is an integral in variable u, that is in a much easier form to solve. So it's just u to the 10th du. We call it a basic integral, and that all we need to do is apply the power rule for anti-differentiation to evaluate it. So the integral is 1/11 u to the 11th power plus c. And now we need to write the answer in the original variable x. So the integral of x to the 4th plus 5 to the power 10 times 4x to the 3rd dx is equal to 1/11 times x to the 4th plus 5 to the 11th power plus constant of integration c. And now there's a slightly, example 2, or B, is slightly more complicated, but not by much. It's the integral of x to the 4th plus 5 to the 100th power times x to the 3rd dx. So again, we let u equal to x to the 4th plus 5. Du is 4x to the 3rd. Notice that just x to the 3rd dx is in the integral, so we divide both sides by 4. 1/4 du is x cubed dx. And so we have x to the 4th plus 5, that's our u. And then x cubed dx is 1/4 times du. So once again, in example B, the integral x to the 4th plus 5 to the 100th power times x cubed dx is transformed by this u substitution to an integral in variable u that is just a very, very basic integral, which is u to the 100th times 1/4 du, which is 1/4. We can take the constant to the outside. Integral of u to the 100 du. Once again, the power rule gives us 1/4 times 1/101 times u to the 101 plus c, which is 1/404 u to the 101 plus c. And all we need to do is rewrite that answer in variable x to solve the problem. So the second example, part B example, is the integral of x to the fourth plus 5 to the 100th power times x to the third dx is now 1 over 404 times x to the fourth plus 5 raised to the 101st power plus c. Now let's look at example 3 or c. Evaluate the integral of cube root of x to the fourth plus 5 times x to the 7th outside of the radical dx. So first thing we're going to do is rewrite this using exponential notation. This will be integral of x to the fourth plus 5 to the 1/3 power, and then we'll take x to the 7th and write it as x to the fourth times x cubed. You'll see why in a second. A U substitution is the same. Let u equal to x to the fourth plus 5. Du is 4x cubed dx, or 1/4 du is x cubed times dx. We also need to solve for x to the fourth. Since u is equal to x to the fourth plus 5, we can easily solve for x to the fourth. It is u minus 5. And now look at the integral. X to the fourth plus 5 is u. X to the fourth by itself is u minus 5. And x cubed dx is 1/4 du. So once again, we have an integral in variable x, which is very complicated. The cube root of x to the fourth plus 5 times x to the 7th. It's a very complicated integral. With this u substitution, has now been transformed to the following u integral, or integral in variable u. So we have u to the 1/3 times u minus 5 times 1/4 times du. And this is 1/4 times the integral u to the 1/3 times u is u to the 4/3 minus 5 u to the 1/3. It's the difference of two basic integrals. And again, all we need is the power rule of differentiation, integration, to evaluate it. Okay, so this is 1/4 u to the 7/3 over 7/3 minus 5 u to the 4/3 over 4/3. And then we can add a c. So this is 1 over 4 times 3 over 7 u to the 7/3 minus 15 over 4 u to the 4/3 plus c. Let's send in 1/4 inside the brackets. So this is 3 over 28 u to the 7/3 minus 15 over 16 u to the 4/3 plus c. And last step is to go back and write the answer in the original variable x. So the integral of cube root of x to the fourth plus 5 times x to the 7th is equal to 3 over 28 x to the fourth plus 5 raised to the 7/3 power minus 15 over 16 x to the fourth plus 5 raised to the 4/3 power plus c.